Bismillahirrahmanirrahim. Welcome to lab module number 5, 3-phase synchronous generator. Okay, for this lab, we shall go through on the test that should be conducted on the synchronous machine. We are focusing on the synchronous machine. So there are a few objective here which being listed. Throughout this task or experiment, you are should be able to measure the parameters and then calculate the armature resistance of the 3-phase synchronous generator. Then we should be able to measure the internal voltage with various field current and sketch the open circuit characteristic of the 3-phase generator. So you are able to sketch the graph of OCC versus IF that we adjusted. So this is our V out open circuit OCC. Then we are able to measure the armature current and calculate the synchronous reactance of 3-phase synchronous generator. So that's our XS. Then able to sketch per phase equivalent circuit 3-phase synchronous generator. So what you have learned inside your class of the 3-phase per phase equivalent circuit of the of the SM synchronous machine. Okay, for section A, armature resistance. So for this experiment, we are focusing on the Y connected machine or motor. So we have before learned on the 3-phase delta connected of machine. So means that we are performing a DC test. What we're going to do is that on this machine should be rotated. So we have VF here, we have a V out here, or V line or V terminal. So when the machine is rotated at the speed of synchronous speed, we will produce voltage, internal voltage EA, then produce the V out, to the external, to the terminals. Okay, but for the DC test, the rotation is 0. The rotation now is 0. So we don't rotate anything. And also the VF is connected as a short circuit. So we don't connect any kind of source to the VF. And also V out is open. So open circuit. So V out connected to the DC. So what we're going to do is that we shall measure the incoming IDC, which pass through our XS, pass through our RE. So we shall follow the Ohm's law of V equal to IR. So the I that comes over the resistance is equal to V over R. So V here is our VDC, R here is our RE, and RE that comes through the R system, R system. So I here is our IDC, equal to VDC divided by that. This is RDC first. We put as RDC because we have two kind of connection. You see, if you have Y connected here, this is Y connection circuit. So V we apply to the circuit. So we will measure I. So this IDC. So RA here is equal to RDC lah. But let's say if we have, or we going to measure in terms of this circuit. See, if the machine is connected in delta. So if we apply DC here, so what will happen is that we have IDC, we have VDC, but here the current will be dispersed into 2 RA. So at this time RA is no more RDC. So means that we have IDC is equal to VDC divided by RDC, not RA lah, RDC at this time. Okay, you can see, because RA now should be recalculated. So here RDC is the same as RA. Here RDC is equal to 3 over 2 RA. You can see 3 over 2. You have to do the RA parallel with the 2 RA here. So you will get the R equivalent. So overall the RDC is equal to 3 over 2 RA lah. 3 over 2 kan 2 over 3. Confirm balik ni. Okay, this is for the DC test. So what you have to do is that you will have to compose the schematic inside your PSIM to perform the RDC test. So this is the example of the circuit or connection. We put RDC. So we can see that this is our synchronous motor with 4 output connection. 1, 2, 3, 4. Means that this is Y connected system. We have 1, 2, 3, 4. So this is neutral. Phase A, B, C. So means that you are connecting between phase C to neutral. So should be RA is equal to RDC lah. Then in terms of your setting, so you select synchronous machine. We have synchronous machine with 0 noted here, or synchronous machine with I or 1 noted over here option. So you just select the synchronous machine option, not with the I here. Okay, because it contains different parameters that you might have or generate different kind of result. So the parameters you have to confirm should be the default value should not be changed and only this part you have to change from 1 to 0.1 NS over NF effective values here. The other parameters remain as it is. Okay. Simulate for 5 seconds of time. Then you fill in the tables here. So you just need to change the DC source. Then you measure how much the DC current that comes into the circuit. So if we have the circuit like this, so this is our VF, this is our V or V out. So we can change the IF by adjusting R adjustable here, or by changing our VF here. So now we are changing our VF up or down. So we have a variation of IF. When current is adjusted, the intensity of magnetic flux at the stator will be adjusted. So we have a different EA. So what we have to do is that we change our VDC source here from 5 up to 25 volt. So the DC voltage source adjust from 5 to 25. Then we measure what is the DC current. How much the DC current? Is that the IF here? How much measured here? Then the DC resistance. So this system we have to calculate. So this one you measure, this one you calculate. Measure resistance, so you calculate. And okay, that's for the DC test. This one you plot for 5 volt setting. So how much the response? In terms of the response on the 5 volt setting. Okay, then section B. I hope I can come back before we start section B. So if I'm not here yet, so you can proceed with section B. whereby the same synchronous motor you use. But the prime mover here, this is our prime mover. You select the DC motor default from the PSIM. It's just that you have to change the rated speed to 1500. Other parameters still the same. So all other parameters are default. Only you change the speed, rated speed. Means that the machine will rotate at 1500 RPM. It will rotate the generator. Then it will supply the voltage to the terminal. So this is on-off switch. You set it at off condition. And the resistor value, use this value, and your phase field voltage, use 100 volt. So it just varies their DC voltage from 100 down to 10 volt. So you record the DC field current and also what are the measured field voltage and on the open circuit. Then by right, you are able to generate in terms of IF versus V phase, and in terms of their VOCC, V open circuit condition or characteristic of the system. It will go up, but it will damp by right. Okay, maximum should be around 240 volt. Okay, that's all for the briefing. I will come back and recap again on this task in the lab later. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.